Good afternoon, everyone, and thank you for coming to the Lockdown Your Learning's weekly seminar here, sponsored by ICT Skillnet. So the seminar today, it's entitled, Where Are All the Clouds Going? And my name is Horacio González-Vélez. I run the Cloud Competency Center at the National College of Ireland. And I'm also sitting at the steering group of Technology Ireland Innovation Forum. If you need to know more about myself, you can always go to LinkedIn under Horacio GV. As usual, this seminar will be recorded, and so if you are not able to watch it live now, it will be set in the ICT Skillnet website. Okay, so thanks. So we'll start. As it's always the case here, we have to introduce the speaker, right? So I'm going to introduce myself. First and foremost, as a good academic, I will start with the Spanish lesson. So Spanish 101, as you may know, the H is silent and the C sounds like S. So in fact, Horacio, it's actually Horacio. So I always say that, in fact, my roots are Irish. So, and even more, if you need to know more about me, you can always ask Google. So if you type Cloud and my first name, Horacio, unfortunately with the standard Spanish spelling rather than with the Irish, you will find me. This is very useful because it gets me upgrades in hotels and in airlines because they think I'm important. So Cloud and Horacio will always get you some background on who I am. I'm always the first in Google. So since this is a seminar that is sponsored by ICT Skillnet, I thought we needed to touch upon the technical side. And I take some of you are very well versed on technical matters and are expecting a very, very technical presentation. So therefore, I'm going for the technical matters first. So, of course, who else but it's the jokes from the technical side. So the typical knock-knock jokes, who is there after a very long pause, you can get Java. You can get, of course, your CSS, which is always awesome out of that. And the programmer's life, which is always a very interesting cycle. And we always say that a programmer, after all, is an organism that turns caffeine and pizza into software. So these are the technical side for the technical people here today. And there are other options that we have seen for the hardcore programmers in the room. So how we've seen over the years. And of course, the Linux people will like that side of it. And of course, as I always say, there are 1-0 types of people in the world, those who understand binary and those who don't. And one of my favorite ones is an SQL works into a bar and talks to 2 tables and says if they can join you. On a more serious matter, I will then, after this sort of comedy part, I will actually introduce the topic today, the cloud. I wouldn't be an academic if I don't start with the textbook definition. The textbook definition of a cloud was roughly coined at the start of the century, late last century, and it's basically the exchange of computational resources where the boundaries are defined by economic factors rather than technical. And in fact, it was at that time, it was typically about on-demand computing, software as a service, and internet as a platform. And in that matter, resources, what it meant was computing equipment, typically processor, storage, and possibly bandwidth. So that was what the cloud was. And up to 2006, if you may recall it, when AWS launched their first offering, it was this, roughly at the same time, the NIST, the National Standard Institute for Standards and Technology in the US launched their first report on cloud computing. And we had basically three axes to define the cloud in 2006. We had three very well-defined models: software as a service, platform as a service, and infrastructure as a service. And we have four deployment models: private cloud, simply inside organizations; community cloud as part of small communities; hybrid between the two; and a public, which was AWS, Azure at that time, and others, IBM and others that started. And much more important, the essential characteristics: the ability to enable the possibility of putting resources together, also known as resource pooling; the possibility of enlarging and getting smaller resources; elasticity, in the same manner that we do with electricity. There was a utility. I don't have to phone my electricity company on a weekend to tell them that I'm organizing a party or that I'm in the lockdown and I'm gonna be staying at home for the entire time and not going on holidays. It itself goes down. I can check my electricity meter in the same way. I can check how much resources I'm using because there is on-demand self-service. The service in itself is measured, and I can access, similar to the electricity, to broad network access. So it was very clear at that time. If you think about 2006, it was clear: three service models, roughly two deployment models, either private or public, and something in between, and the five essential characteristics typically defined by the NIST model. So that was then. But then, over the years, 15 years later, we're seeing that everything is moving to the point that it's no longer a single cloud. If you check, last time we were counting, there are about 25 different service models. I mean, we used to talk about just SaaS, PaaS, and IaaS, so software as a service, platform as a service, and infrastructure as a service. Roughly, software as a service is what we all use today by accessing the cloud with Outlook or Gmail or any service like that. Platform as a service, the possibility of offering infrastructure plus a development model, and the infrastructure, which is simply the computational resources plus an operating system typically. So that was then. But now we have analytics as a service, databases as a service, function as a service that has become much prevalent, also known as serverless computing, and a number of others, machine learning, artificial intelligence, you name it. Everything can be named now as a service. And from the traditional deployment models of private, community, hybrid, and public, now we are thinking about federated, clouds themselves that can interconnect to each other in a federated manner. That means they still retain governability issues across, but they can be accessed in between. There is distributed clouds, multi-clouds, poly-clouds, big data clouds, HPC clouds, you name it. There is now countless deployment models that are targeting different markets and users. And that makes sense when you have specific needs and, more important, specific computational resources associated. I don't know, if we are talking about an HPC cloud, probably you have non-von Neumann architectures, meaning GPUs, possibly tensor computing, and very soon we'll see even quantum computing being part of the deployment models, where you can offer a service with the five characteristics. Plus, now we're looking at additional characteristics, such as multi-tenancy, which has become a fact. We have to share the different scenarios. There is now much more important the performance, the quality of service that a cloud is delivering. There is the availability, the famous 5 nines. So we want to have a cloud that can be up 7/24 with at most 5 minutes of on-plan maintenance. So security, device agnostic, so a number of characteristics that we're looking. So if you look at it that way, we are no longer looking at a single cloud. We're looking at multiple combinations of them that can suit the needs of specific parts. I always like to see that this is the way. So it's, to a certain extent, these days we're looking at a Dilbert scenario where people just start adding together jargon and start adding the possibilities. But after all, we should bear in mind that what we are looking is elastic computing, the possibility of accessing through the internet, and still the same computational resources that are exchanged through boundaries and the internet. So after all, the definition hasn't changed. It's now the characteristics of them. But if we want to make sense of those, and if you really need to do a much better part, I strongly recommend that you ask the experts. And this is, of course, sponsored by Skillnet. So I need to mention that now the applications are open for the MSc in AI, artificial intelligence, and the MSc in blockchain. If you want to know more about these programs and others that are offered by ICT Skillnet, go to ictskillnet.ie, training programs. The URL is right there. And I'm sure you will find something that suits your needs and can improve your skills in a certain part. So don't be just like Dilbert playing the letter soup. So after all, taking into account that we know where we were, the question is, where are we now? So the idea of this presentation is to bring us where we are now and try to elucidate a bit about the future. As always, it's very difficult because talking about the future is almost bound to be incorrect. As you can see at the background, there is my lab, the Cloud Competency Center at NCI, and this has been the place where we have tried to train people. We now are reaching the milestone of hundreds of graduates from the program, and we always want to teach them how to learn because that's important. They will keep on learning in that sense. So this is the purpose of this. Improving your learnings towards the future. So one thing I just run a word cloud over one of the seminal papers that was published last year by Raj Bhuya and some 20 authors, leading experts in cloud computing. It's called A Manifesto for Future Generation Cloud Computing. It's in ACM Computing Surveys, and it was published last year. And as you can tell right there, what it brings is it's going to be, of course, about data. Make no mistake, data will be the dominant side of that. So data-intensive computing in general. And of course, there are now much more we're seeing IoT, as you can tell here at the right at the bottom. Fog and edge computing are now starting to be important. And in general, multiple domains, multiple users, memory intensive, and something that it has become even more important that whatever we're doing has to be energy efficient and at least energy aware. Okay, so if I'm an organization, regardless of the size, how do I choose cloud providers? So this has to be, tends to be a bit funny because it cannot be just like throwing darts at the board. We cannot choose the organization. We cannot choose the cloud provider by just throwing theirs at the board. What is the best way to choose a cloud provider? How do I know what service model? How do I make sense in a digital transformation or to improve already the cloud services that we have and that we are offering? So from that perspective, something that serves us that, and it's for those of you who are a Star Wars fan, you will know that this is the Jedi. And of course, last October, the largest contract ever was awarded. It's called the Jedi. In the U.S., it was awarded by the Department of Defense, Department of Energy in the U.S. And the original winner was Microsoft. It's being contested, and to this day, it's 522 is still in the courts because there is a dispute. It's not been. So that only tells you how difficult it is. So the 10 billion Jedi contract is still there. So things happen. This is not as simple. Even a tender in the U.S. government that they have long track record of going in that respect hasn't been easy. So one thing that most experts tend to concur on is try to make sense of the performance of a cloud. And how do you measure performance? You can measure performance in response time. Response time from the application all the way, because people tend to measure performance just at the host side, and clearly this must be misleading. So we're talking about performance time all the way, response time all the way to the user, which has to be under 2 seconds. Throughput, that means units of work per time. The utilization of resources, it's very important. Of course, if I buy a 200-seater and I'm just taking 5 people in they are going to be very comfortable, but I'm paying for extra seats. So that's the sort. So just make sure that you're using what you need to. I was just reading this week that a couple of providers, namely AWS, have now improved their estimations of resource utilization in order to allow users to choose the right size of instances by using the history of their utilization and in a predictive manner tell them that they require a smaller, a bigger instance or type of service, and even better, what sort of reserve instances of that. And last but not least, the latency, how long it takes, how long you have to wait. So that's 4 criteria that you can take into account when selecting a cloud. The other one is the SLA. The service level agreement is a typical one. So it's I call it the nines dance. So how many nines you want? So of course the 5 nines, which is the gold standard, 5 minutes without service per year. But of course, most of the times is some of the fine print doesn't take into account planned downtime, service interruptions, or even better, what happens when the SLA is not met. So I have an SLA of 5 nights with my cloud provider. Does it mean that after 5 minutes, I have to get compensated? Do I have to get additional sites? What is the commitment? So that's the liability. And clearly, if you are just a normal individual user, might not be that important. But of course, a financial institution, a small, medium enterprise, or someone that relies their operations on the cloud, that is very important. The other one is the APIs. APIs are great as long as they are compatible. So typically the issue is that APIs are not necessarily multi-vendor. They have to be multi-vendor. I have to have application programmer interfaces that can be using different platforms, different clouds. Do I have does the cloud that I use, it's multi-stack? That means OVF compliant. So that means I have a workload with a particular configuration, software and hardware configuration. Can I transfer that? So I take a snapshot. So I checkpoint that. And can I transfer that one-to-one without problem? That will mean that it's OVF compliant. So the Open Virtualization Format will enable that. And most vendors say that they are OVF compliant. How that is done, it's different. And sometimes they tend to have also different parts. So I'm using a given cloud provider. Does my application certify their software in a given platform? That's very important. So that is a bit of a lock-in factor. So that's it. So these are additional things that I have to take into account. And after all, this is mapping to the TCO, the total cost of ownership. Traditionally, in the olden days, Gartner's came up with the TCO as a model to say, well, it's the hardware and software, the management, so direct cost, indirect cost, and all that. For in the cloud times, it's much more important to talk about cloud provider and licensing, administrative and support, the communications, the devices. As you may be more than aware these days, one of the biggest expenses of this time when all we've been at home and quarantine is the devices. So some of the infrastructures were ready to support working from home, telecommuting in general, but not necessarily the devices for the final users were enabled, were maintained, were updated. Not everyone knew how to access them. And there's also, as part of the TCO, there is the usual opportunity cost, downtime, training, others that are indirect, that are not necessarily at the very beginning. So with that, I will say that's the way to select. Now, what is coming? What should I expect in the cloud? What is going to happen now? Okay. So the first and foremost, after talking about interoperability and all that, it's going to be multi-cloud and orchestration. That means we cannot be reliant on a single provider with a single software stack with that. It's going to be multiple. I may require some machine learning services from one cloud provider, which need to talk to my administrative software in another cloud provider, and I need to get them working. So I have some predictive models that can work on one and need to be, and it's going to be about orchestration. It's going to be about the possibility of interconnecting the different services in an orderly manner, and that can be. So that's going to be a fact. And this decade will see a simple, clear standards to have that multi-cloud and orchestration. And the other one is that we will be more reliant on hybrid and private. That means many people, when they talk about the cloud, they think about everything has to be in a public cloud provider, namely, I don't know, Microsoft or AWS or IBM. Not necessarily. You can have private clouds, but not with OpenStack, where you have your own cloud with all the functionality, with the different levels and orchestration. And at some point, you can elastically expand into public cloud providers for specific functions in a hybrid manner. So that's what I mean. You can have operations on a cloud level at a private organization, expand interactively in a hybrid manner, and rely. So certain computations can be offloaded to the public cloud. So that's going to be more. The other one that has been quite important recently in Europe is GDPR. whatever you have to be doing is had to follow data privacy, has to have governance, have to comply with standards, have to be doing that. So in Ireland, we are quite fortunate to have been one of the first countries to release a cloud standard via the NSAI. We had the Swift 10 standard for cloud computing. It was released a few years back, start of the 2010s. And we've been quite at the forefront of that. Clearly, with GDPR, it's not only Ireland, it's about Europe, it's about standards, it's about maintaining privacy, making sure that data owners know who they are and records are kept there. And last but not least, automation. We need to have automation in all that we need to do. The other one that will be haunting some of our technical people is Kubernetes. Kubernetes will be out and serverless will be in. So that's something that has been clear. So containers are cool, but they will be less prevalent and will be used by serverless, which after all is containers, but now invoked through functions. Because after all, I always say cloud compute is going to disappear. It's going to become simply computing. We have to look at it in that way. Cloud will become computing, will be the way to do operations, because the next frontier is infrastructure. Infrastructure is what it counts. These days, we see that much. It can be great that I have the best access at my job, but if I don't have access from home, I don't have anything. So it's about personalization. I make no secret that I love American football. And of course, the draft, the NFL draft, is a historic moment every year in Las Vegas. But this year, of course, due to COVID-19, couldn't be done. This has been now an exercise of technology. The draft will never be the same. The NFL draft will never be the same. It was mobile, it was feeds, it was production control, it was television, interaction, personalization. It's totally different. The other one is privacy. Of course, a bit topical here, but the fact that someone knows who you have been with is interesting, but sometimes scary. So only the right applications have to know where you are, how you're doing, what word you're talking. So this is, of course, the contact tracer from the NHS in the UK. So this is an interesting, it's going to be rolled out very soon. So this is just the part of what we're doing. In 2019, these were the sort of deals that were done. So Salesforce, of course, acquired Tableau for $15 billion. So two companies in the cloud. NVIDIA acquired Mellanox, very interesting. GPU computing acquiring a fast networks company. Both of them, InfiniBand, the standard in data centers, GPUs, artificial intelligence, VMware acquiring Pivotal and Carbon, Google acquiring both Fitbit and Looker, Salesforce with Click Software, Microsoft for Verve, Mirantis and Docker Enterprises. But the dark side in 2020 is what is happening. Those companies who weren't necessarily prepared for online operations, unfortunately, some of them, most of them have been in the retail. And we have seen J. Crew, Neiman Marcus, JCPenney, Pier 1, Goldshine, and Hertz going into Chapter 11. Companies that have several years in operation now looking at restructuring and filing for bankruptcy. So it's a totally different structure year to year. And of course, everything will be about performance. So we're going to see for the first time very soon, it's expected to be by next year, the first exascale computer. The kilos means thousands, then megas, millions, okay? And if you keep on that side, gigas, teras, petas, and exas. So we are looking at these trillions of floating point operations per second in a machine, okay? And above all, it's going to be about possibilities. It's going to be about the possibilities of improving and exercising the power of the cloud. So if you are interested in learning more and understanding how an organization will expand into this, ICT Skillnet have 2 programs that can help you learning about this. The first one is the Innovation Excellence Program, and also there are workshops in digital transformation. And that's an interesting part. So I'd like to thank you for your time this afternoon, and I'd be more than happy to take questions at this point. The first one, it says that, why do you say that Kubernetes will be out and serverless in? The Berkeley's view on serverless is that Kubernetes will have a backend on serverless, and AWS have started to dedicate service on Kubernetes. That's very, very well informed. In fact, there is clearly the Berkeley view. It was a report, for those of you who know, in February 2019, the University of California, Berkeley, released a report, also known as the Berkeley view on serverless computing. And of course, they give a very interesting follow-up to their famous cloud view from Berkeley. And they say that containers will be there. But in fact, what I try to explain in the Kubernetes South and serverless in is basically containers per se will be embedded into the serverless computing. So to a certain extent, what is happening here is that this serverless side, it's embedded in a container. So when you invoke computation, serverless computation, what happens is it creates a container, which is at the back end, and it stays alive while the computation is in, and then returns and builds the user on a time. So that's what I mean. Kubernetes per se will be superseded more, or will be evolved into a serverless computing. So in the long term, it's expected that people will be using serverless computing that just simply containers. That's what I try to mean with this. Another one is how fog computing is related to cloud computing. So as I did mention a trend, which is fog computing, and this is so when you have clouds and just devices, there is clearly the possibility of just uploading the full computation into the cloud. But devices have become more powerful by the day. So we now have multi-core processors, potentially even 4 cores in a mobile device, in a telephone, in a smartphone. And if you take into account, let's say, stadium, in the good olden days when people, last year when we could go to watch the All-Ireland final or whatever, you have potentially hundreds, if not thousands, of smartphones together that could cooperatively perform a computation instead of offloading directly into the cloud. So what is happening more and more is fog computing enables the possibility of having micro data centers. That means centers closer to the users, and by calculating thresholds on processing, you can offload to micro data centers rather than to the cloud or directly to the cloud. So that's the difference between that. There is is it ever possible to make an application cloud agnostic? In principle, the possibility of making it cloud agnostic is as possible as having it compliant with standards. So if I have applications that can follow standards in the sense of OVPs, OVFs, and possible APIs could be, but clearly at some point there will be dependencies to the software stack. So in principle, theoretically you can, and really in practice there will be some hooks on that. Is there any way to prevent a cloud provider lock-in? That's a very insightful question. I suppose it's as much as possible, we would like to believe that car or driving is independent of the manufacturer of the cars. I mean, you can drive, a Beamer and a Skoda or a Ford, and strictly speaking, they're independent. But once you start looking at the car and certain characteristics and all that, there is a lock-in. There are certain characteristics and ways of doing things that will depend on the vendors. The same manner happens with cloud. So at this point, most of the operations are independent of the providers, but still there are dependencies depending on the marks, the stacks, and the providers. So edge computing is the next step to focus. So that means not only I offload to data centers, as in fog computing, micro data centers, but I can perform computing at the edge. That means at the devices, and basically I can do peer-to-peers and all that. So I wouldn't say that edge computing is just the future. It's going to become prevalent in certain characteristics. I don't know, disaster recovery. Imagine there is a natural disaster, and we need to compute things between peers. That would be edge computing. But I would say they coexist. How are the gateways secure time when we have to back up and turn serverless computing? Well, first of all, backups are part of a cloud provider, and clearly cloud providers now operate in a secure manner backups and can and typically retain multiple copies of data. So the ability to do tunneling and backups is now part of any standard cloud offering, certainly at the enterprise level. So this is quite common. Without further ado, I'd like to thank you all for having me here, and I wish you a great day and have a great time.
Thanks for watching. If you enjoyed this webinar, please follow us on Twitter and LinkedIn to be kept up to date with all our news, events and programs. You can also subscribe to our YouTube channel for more videos like this one.